So I wanted to talk through an example where we solve an algebraic equation and we justify each step with a property of equality. Now, this is a little bit different probably than what you're used to. If you were taught algebra like I was taught algebra, you probably weren't taught each one of these individual properties. But you're already using them. You're already doing this in your head. You might just not have a name for it, right? A lot of times we just say, do the same thing to both sides when we talk about solving equations. But here we're actually going to define exactly what that thing is that we're doing. Okay, so let's go ahead and try this out. Now, you'll see this a lot in our class and in geometry. We call them two-column proofs. It's a way of doing proofs. When I was in my higher levels of learning in college, it was almost like writing paragraphs. So we did almost like a paragraph style proof. But two-column proofs are really nice because they're really easy to follow, right? They're really easy to lay out and structure and justify everything that we need to justify. So the first step to writing our proof for this problem, we're solving this problem. We're going to prove what x equals by using these different properties of equality. The first step is always just to write the problem. I've got this problem right here. So the first step is always just to write out the problem. 2 times x plus 2 minus 5 equals 3 minus x plus 1. And and so we number our steps just so that we can see whatever I'm doing on the left, that corresponds to the same number over here on the right. And we call that our given, right? The problem is always what's given to us. And as we move on, it'll be different bits of information that are given to you, but now what's given to us is the problem. Okay, so the nice thing about proofs is that while there is a correct answer, there is one correct answer, there are multiple ways to get there. So, well, you might see a different next step than I do. I would encourage you to pause this video and maybe just solve the problem yourself. Try to justify it if you can, and then come back and see the way that I solved the problem. See if it was the same or different than what you did. Okay, so hopefully you've thought through it a little bit, but here's my approach. I'm going to use the distributive property right here to distribute 2 to x and distribute 2 to 2. 2 times x is 2x plus 4 minus 5 equals 3 minus x plus 1. Okay, and so we need to justify that, right? We used the distributive property. So we used the distributive property. So on my right-hand side, I'll just write distributive property. Shorthand's okay. With me, I don't mind it. Okay, and you don't have to draw these arrows in between your steps. I just did that so that you can see what I'm doing. Now, the next step that I see, the obvious step, is to combine my positive 4 and negative 5. And I don't really have a property for this. It's not the same as the subtraction property of equality or the addition property of equality. So whenever we just need to simplify things, like this is 2x, 4 minus 5 is negative 1, 3 minus x plus 1. I'm just going to call that combining like terms. If you want, you could write CLT. I'm okay with that. We're combining like, this kind of sounds like a sandwich, right? We're combining like terms. It's tasty. Makes our solution a lot more elegant at the end of the day. Yeah, so I'm okay with that. Let's combine like terms there. All right, so now I'm seeing 2x minus 1 equals 3 minus x plus 1. I kind of like moving this 3 over, right? Subtracting 3 from both sides. So if I'm subtracting 3 from both sides, what property is that? Well, it's the subtraction property of equality. So here we get from 2x minus 1 equals 3 minus x plus 1 to 2x minus 4 equals negative x plus 1. And we got there using the subtraction property of equality. And I know that's a lot to write out, but we want to be specific with what we're doing, right? We are using the subtraction property of equality, not just the subtraction property of anything, right? Okay. So now I've got this bit right here, and my next step is to distribute this negative x plus 1. Okay, so distribute that negative. 2x minus 4 doesn't change. That equals negative x minus 1. And we did that using the distributive property again. And you might have noticed, hey, I could have done in the first step, or between steps 1 and 2, I could have done the distributive property on both sides. And yeah, I'm okay with that. If you want to use the distributive property on both sides and just combine that into one step, that is okay with me, as long as you're using the same reason. You shouldn't be using multiple reasons for the same step. Okay, so, and we'll see that here too, because well, I need to do something with the x's and something with my constants, right? So I'm going to go ahead and add 4 to both sides, which leaves me with 2x equals negative x plus 3. Cool. Okay, and now what property did I use to do that? That's the addition. Oops. That's the, I'm going to go ahead and move us up a little bit. That's the addition property of equality. And then we do the same thing. Add x to both sides. 3x equals 3. That's also the addition property of equality. And again, I think I personally would be okay if you wanted to just say, up here, if you had wanted to say, well, I also want to add, I also want to add x to both sides, right? You could have combined those into one step. Either way, I'm fine with it. Just make sure that it's the same property that you're using. You're not using different properties. If that was subtraction, it would definitely need to be 2 steps. Okay, last but not least, we're using 3x equals 3. I want to divide by 3 on both sides. Go ahead and extend this. So 3x, well, normally I wrote that in green, but that's okay. That's x equals 1, and we used the division property of equality for that. We use the division property of equality to find that x equals 1. And then we're done, right? That's it. We have finished our proof. So, yeah, so there you go. That's how we can use these different properties of equality to solve what seems like just a normal algebraic equation. But we justify each and every step so that if anyone tried to poke holes in your argument, they wouldn't be able to, because each step is fully justified.